Hello everyone, welcome to SCI-EASE. In the last video, we discussed about electric current and circuit. Now in this video, I will tell you about the electric potential and the potential difference. First, what do you mean by electric potential? Electric potential at a point in an electric field is defined as the work done in moving a unit positive charge from infinity to that point. So, this potential, electric potential, is sometimes known as potential only. Potential is denoted by the symbol V and its unit is volt. More common term in electricity, that is potential difference. Very important term. The difference in the electric potential between 2 points, that is known as the potential difference. Potential difference between 2 points in an electric circuit is defined as the amount of the work done in moving a unit charge from one point to the other point. So, the expression for the potential difference, that is equal to work done over quantity of the charge moved. Or you can say V is equal to W over Q. So, what is W? It is the work done. And what is Q? It is the quantity of the charge moved. So this expression, that is potential difference is equal to work done over quantity of the charge moved, is again very important. On the basis of this, sometimes you have to calculate the potential difference. Numericals, they are there in the exam. Sometimes you are to calculate the work done. So in that case, W will be equal to VQ. Now what are the SI units of potential difference? It is volt and it is denoted by V. Sometimes potential difference, the abbreviation for it is also written as PD. That's why I have written somewhere in the text. The potential difference between the 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of the electric charge from one point to another. So, we can write this like, if this V is 1 volt, W is 1 joule and Q is 1 coulomb, then it will come out to be 1 V is equal to 1 J over 1 C. Or it can be written like this, 1 V is equal to 1 J C inverse. So this expression you have to memorize. Many expressions, they will come in this lesson. You will form a table and pin it in your book. The formulas, all the formulae you are to write and pin it up that paper in the textbook. And whenever you open the book, you go through those expressions, those formulae, and you can memorize them easily. So one thing I must tell you, that the instrument by which the potential difference that is measured, it is voltmeter. Electric current that is measured by ammeter. And here the potential difference that is measured by the instrument known as voltmeter. Ammeter that is always in series in circuit, but this is voltmeter that is always in parallels, that is always connected. Suppose this is the conductor of which, across which the potential difference is to be calculated. This is a conductor. So voltmeter that will be connected in parallels. So these things you must memorize. And this voltmeter, it has high resistance so that it does not take the current from the circuit. So this is all about the electric potential and the potential difference. In continuation to this electric potential and potential difference, I will discuss here two numericals, because I have told you that this expression is very important. Now, the first numerical is how much work is done in moving a charge of 2 coulombs from a point of 118 volts to a point at 128 volts. So solution is, the expression here is potential difference that is equal to work done over quantity of the charge moved. Now what is V here? We are to calculate V. It is 128 minus 118. That is equal to 10. What is the units of potential difference? I have told you, volts. So this is 10 volts. How much work is done? We are to calculate work. Work is to be calculated. And what is the value of the charge? Q, that is equal to 2 coulomb. You must write the units and the numericals, otherwise half mark that will be deducted. Now putting the value in this expression, 10 is equal to W, we are to calculate it. Q is 2. So W that will be equal to 10 multiplied by 2 is equal to 20. What are the units of W? Joules. So simple numerical. But you have to practice, then and then only you will be able to solve it. Now come to the second numerical, that is how much energy is given to each coulomb of charge passing through 6 volt battery. Here the potential difference that is given. Okay, potential again, the formula that is V is equal to W over Q. Here potential difference V that is equal to, that is given 6 volt. Now how much energy? Work done here is equal to energy. whatever the value of W that will come, that will be the energy. So we are to first calculate W here. And Q, what is the value of Q? Each coulomb. Each coulomb means every coulomb, 1 coulomb. Here Q is, value of Q is 1C. So putting the value in this expression, V is 6 volt. W we are to calculate. Charge, quantity of the charge moved is 1. So W will be equal to 6 into 1 is equal to 6 joules. So I have told you that the work done is equal to the energy. So the energy here, that is again 6 joules. So very simple numerical, but you should know the expression, you should know the units also, and numericals, they will definitely come from this chapter. So be prepared. Thank you.